Hello, Forecaster here again, and we are back for episode 209 of the Minecraft Let's Play. And today we're going to do something special. We're going to poke a little at a new mod. And in preparation for that, I have to make a few open computers components. So I'm making two PCBs, printed circuit boards, and with those I'm going to be making a tier 1 computer case and then a tier 2 computer case. So let's pop down to the factory and get some components. We have a microchip, and then we just need a chest, which is easy enough to get, and a couple of iron bars, which I should have somewhere. Pretty sure I have a bunch of those, quite a lot of those actually, probably. Let's see, there's two of those, so we make our chest. I'm also making more wooden posts, which I'm going to use to keep extending the high-speed railway, which I've been working on. Now for the tier 2, we need 3 microchip tier 2, which I do not have, but we can make those easily enough. The factory should be able to help us with that, so let's turn it on. Factory is still kind of not working as well as I would like, but there should be enough life in it to make these. So I need tier 2 microchip, which is number 4, and then we need 3 of them. Hopefully that works. This is making tier 1 microchips for some reason, even though it already has a bunch of them, which is one of the many problems with this thing that I need to fix. I'm going to redesign it a bit when I move it or set it up in the new base. Are you not pulling out stuff? Okay, there we go. What are you doing? Crafting 2 of microchip 1. Right? Are you not able to pull out? That should be the transistors. I'm having some server lag. This should be the tier 1. It's out of quartz, is it? That's kind of important. One of the things that are going to change is that the factory is going to hopefully have access to my entire storage pool of resources, so that things like this don't happen. So let's throw that in there, and that should give us what we want. We then also need 4 gold ingots. So that should leave us with at least 3 of those. Factory is still nice to have, even if it doesn't always work right. So there's our computer case 2, and we are not going to use that as it is. We also need a bit of a cable, and then we need a minecart, because we are making a computer cart. Now we're also going to need a bunch of components. Where's my assembler? There it is. Right. So the computer cart come from the OC-Minecart mod, which is obviously an Open Computers add-on, and it's basically a robot in a minecart that rides along a track, and it can do a variety of things. Like I think it can place blocks and stuff. I'm not entirely sure, but I'm going to do something a little bit special with it. So I'm going to be back. I am going to make the components for the actual computer, which is basically a robot. You need a CPU and a hard drive and things like that, which is going to take a little bit to craft. Going to require more printed circuit board for the memory and such. Need a screen and a keyboard and a graphics card. So I will return when I have those things. So I will see you in just a little bit. Alright, so we are back, and I've been crafting stuff, of course. So, as you can see, I've made all of the components. We have a keyboard, a screen, disk drive, a graphics card, a processor, some memory, the BIOS, and a hard drive to install the operating system on. Complexity 7 out of 100. That is barely anything. But the reason that I need a tier 2 computer in this machine is because of this, the navigation upgrade. It's made from a map, which I made right here, and that determines where the point of origin is when navigating. It uses 2 tier 2 microchips and some gold, and it is, of course, a tier 2 upgrade, so it needs a tier 2 computer to be able to use it, otherwise it wouldn't go in. So that is why I'm using a tier 2 case for this, and it needs to go in one of the tier 2 slots, of course. So I'm going to assemble this. It's going to take a little while, 2 minutes, which isn't terribly long. Now, I have a program that I've written for what we are going to do, and it's going to use the navigation upgrade, of course. And it's not really going to navigate. I can say that much. Now, interestingly, I also got this, well, when I made the hard drive, which is something, apparently, that will happen during Christmas, which is when I'm recording this, of course, and this video will be going up tomorrow, so it'll still be around Christmas. But apparently you can get these, and I'm going to open it and see what we get. Oh, a database upgrade. Alright. Let's say no to that. So the program, I have it right here. And based on this text, you can maybe get a hint of what it's supposed to do. I have it on this floppy disk, which is one of the reasons I put a floppy drive in the robot. Now, I also made... I can turn this off now. I also made these, the network rail controller and a network rail. Because I wrote the program to use these, but I realized that I don't need them and adjusted the program slightly, so it should allow me to not have to use those. And there is a reason I used those, but they aren't really required. Now, I've been doing some other stuff as well. I've been running these. I actually added a bunch of recipes for wood. So, in the block cutting machine, I've pretty much added all the woods that I have in my mod pack. So it includes forestry woods, biomes of plenty woods, and there should be twilight forest woods in here, wood in here as well. And they all turn into 6 planks instead of 4, at the cost of time and power, of course, because it takes time for these to run, and they use quite a bit of power while doing so. There's our cart finally done. Now let's see the operating system there. I don't need this. Now we are going to go up to the train station. What are you doing? And we're going to plonk this down. How's the coolant processing starting up or stopping, perhaps? Who knows? I've been running ore processing and the block cutting machine, so it's been using a bit of power. Now I'm going to disconnect this here. I'm going to push this forward a bit, and it is raining. We'll put this down here, and it looks very funky. And you haven't seen this before. I don't think I've done anything or shown anything with this on camera. Rain noise. That is really distracting. I'm actually going to turn the rain off. So, like I said, this is basically a robot in a cart. Now, because we put a disk drive in it, we have a slot here that we can put floppy disks in. I'm going to start it up with the OpenOS disk in, which is going to start OpenOS. We're going to install it onto the hard drive, because we need to take this out. I'm pretty sure you can, similar to a robot, you can switch out the EEPROMs as well, if you feel the need to do so. Not enough memory. Okay, so there isn't enough memory apparently to run OpenOS properly, so it will be running in low memory mode, I think. But I think it should work still. Oh, no. It's not. But I think we should be able to do this. Can I? Ah. Okay, so it didn't load properly. So, one stick of tier 1 memory is not enough. So what I'm going to have to do is I'm going to have to disassemble this, and I'm going to make some more memory and put in it. So I will be back once I've done that. Alright, so we are back again, and I've been making some more memory, and it looks like I need to make another batch, or the factory is going to. So I'm going to put in 2 1.5 tier 1.5 sticks. That should do it for that. Let's give me 2 of those, and then I need 3 more of those, so that is perfect. Don't do that. That happens sometimes. Okay, so 2 1.5 should do it. Fortunately, I didn't lose anything when I disassembled this thing, which is nice. It's all still there, I'm pretty sure. I'm going to assemble it again, which is going to take some more time. So the program is a speed tester, or yeah, pretty much that. What it does is it loops every second, and each time it checks the position of the well, the robot or computer, whatever, using the navigation upgrade, and it compares it to the last position, and it will use that to calculate the speed the upgrade is moving at, basically. And it will calculate over time an average, and then at the end of the program, you're going to get the highest speed that was reached, and also the total average. Let's see. I actually need to make a change in how the program works. I realized I don't have a way to stop the test. So I'm just making a quick adjustment. So then we are going to have to put the floppy drive back on this, which means disconnecting it from the factory, because otherwise it won't be able to interact with, or there will be too many components, so it will fail. So let's exit that, and we are going to go into mount, and then go into 7C, which is the floppy drive, which has the speed test on it. We're going to remove that, and then edit speed test Lua to create a new one, new empty file, which I can paste the program into with the changes, which is because I'm editing it in an external program, because the in-game editor is, of course, a bit slow and annoying. It's not the greatest. So this is done. Perfect. Now we're going to head on up to the train station again, connected to the train, and it should start OpenOS properly this time. And we should be able to install it and then put in the program disk. Let's put that down, start it up. Alright, put that in, then start it up. And then while it's doing that, we can link it. The funky transparent strip there, I'm pretty sure that is not supposed to be transparent. It's supposed to be solid like the robot one. It might be a rendering error caused by other things. Certain things have a tendency to mess up the rendering of other things. So let's just install OpenOS so that we can remove the disk and not have to worry about that anymore. And also so we can save stuff on the hard drive. Because if you don't install OpenOS, it won't allow you to, or will the default, I mean, you can navigate into the hard drive if you want, but it's generally a good idea to install it. But mostly it's because I don't want to have to keep putting the disk in. Now I didn't put an inventory in this, no inventory upgrades, and it doesn't have one by default. So again, I might want to do that at some point. But I'm not going to worry about that now. Maybe I'll make another tier 1 one. I don't really want to. I didn't lose anything this time, but I could next time. So we're going to go into mount, and then the floppy drive should still be, it has this, the address doesn't change, of course, so it's still 7C6. And here we should have our speed test. So I'm going to start the program. Oh. End expected close function. Ah, right. I got a piece that I didn't mean to when I did the change, the last one. So let's try that again. Let's remove speed test. Can of course edit here as well because I have OpenOS. So then we're going to create a new speed test.lua, paste the new version in here, and I have already put this up on my repository where I have my OpenOS or Open Computer programs. I'm going to keep it up to date, of course, with these changes, and I'm going to link to that in the description so you can have a look at the program itself if you want. Now we should be able to run the program, and now it's going to wait for a key press. So I think when I press escape it's going to start. I might as well start it. So there we go. You can see the average speed is 0. Now we're going to jump into here. And I should probably have started this earlier. But you can see now that it is measuring the train speed. And I want to flip this. So every second it outputs the current average speed. As it can see it, I'm not sure what this is about. Might be some discrepancies between the server and the client, so it was actually moving on the server when that happened. Oh wait, crap. I don't want to go on the high-speed track now. What I'm actually going to do is I'm going to stop it. So this is what happens when you stop the program. It will summarize the total average, and then it will note the highest speed it reached, which was 3 meters per second. Of course, it's not super accurate because it relies on the timing of the computer, which is not always on point, especially with lag and such. But we can restart the program now. Send the start signal, and then we're going to get in. Wait, what are you doing? Let's do that. And now we're off. Oh. Hold on. This didn't happen before. Attempt to perform arithmetic on local X. Huh. Okay. 64. Is that... Does the navigation upgrade, is that failing? Right. It has the navigation upgrade. You can see right there. And that's very odd. I'm not sure what is happening there. I'm doing a last x minus x, where x is a variable from the navigation upgrade, its get position method. So this worked in the test world, and it was all with this same mod pack, so the versions are all the same. I don't know why that happened. Let's try again, shall we? Let's run speed test. Start. And it fails. Maybe something is messed up. Let's reboot. Although all variables should be local to the program, so it shouldn't store them between the runs. And it also overwrites them on startup anyway. I'm not entirely sure what's going on there. I wrote and tested this program in a creative world. Can I run this? I don't think I can do that. No, I need to go to the floppy. So run it again. Start signal, and it fails. Why does that happen? Why? Last X shouldn't be Neil. Maybe I should do that. Move the line. Let's remove. Yes. Remove speed test again. Edit speed test.lua. And we're going to paste the new version in here. And run that. Start. Attempt to perform arithmetic on local last X and nil value. So the navigation upgrade has to return nil for some reason. But why? Alright, I'm going to have to look this up. I'm going to have to look up the navigation documentation and see what the return. Okay, returns nil and the string out of range. Oh. Returns nil and the string out of range if the robot is too far away from the point of reference, i.e. when it's out of bounds of the map that was used to craft the upgrade. I see. So, because I used a map that only covers the area right here on the base, when over there I probably left it. So that explains that. So what I need to do is add handling for that in my program, because I didn't know that could happen. I kind of just assumed that it would just use the point of origin and not care about the distance, which obviously turns out to be false. So I'm going to have to add detection of that error. So I have to check the first X and each X to see if it's nil, and if it is, that means that that error triggered, and if not, and I'm also going to have to disassemble the cart again and put in a map in the upgrade that has a higher zoom level, so I get more distance out of it. Now I want to show the program off properly. So what we are going to do is we're going to go into my creative test world, and I'm going to show you what it does there. So I will see you in a little bit when I load that world up. Alright, so here we are in my test world, obviously. And here we have a creative computer cart with the program on it. It doesn't have the latest version though, but that doesn't matter. So I have a bit of a test track set up here. I've been doing some tests with high-speed tracks because that is interesting. There will probably be a video about this, about speeds and stuff soon, a Railcraft video dedicated to this. I need to run a bunch of more tests before then. So the way I originally wrote the program was to use these network rails or tracks, as they should be called, by Railcraft standards, to start and stop the test. So as you can see, I have one right here. So when the cart would pass in this direction, it would start the test when it comes here. And then when it comes back, there's a loop on the other end, it would come back, and when it passed by here again, it would stop the test. I'm going to put one here. And I'm going to put another one over here, so we can start and stop the test. So you can see now that it is waiting for a starting signal, and there is no override. If I press a key, nothing is going to happen because the this version of the program doesn't have that. So the train is set to forward, max speed, and running. And if I press this button, the holding track there is going to release. And there you can see the start signal is received, and it's going to go around the track, and then come back here and stop on this locking track there. And this is a non-creative cart I had for some other testing. So now we can see that it ran for about 15 loops, which should equal to 15 seconds optimally. Reached a top speed of 10.6 meters per second and an average speed of 8.16. Now, of course, the lower average is, of course, because it slows down during turns and such. And if we have a look at the track, you can see that we have a couple of sharp turns here, and then we have a diagonal bit here. Now we're going to remove this, disconnect this diagonal bit, and we're going to do a quick test. So if we run this again, it's going to reset all the values, set it off, and it's going to go around the track. Now what I want to try is to run it once with the 90-degree corners to get a base value for control. So we had a top speed of 8.4 and an average of 7.5, and I am actually going to note that down. So average 7.5, and top was 8.4. And these values have a tendency to vary a bit even between identical runs because of the nature of Minecraft, probably. But now we're going to do this. So we create a little bit of a curve. Whoops. And we're going to see if that increases our average speed any. Let's get rid of this. Do that. And then we are going to start the program again and set it off. And it ran for 12 seconds last time. We'll see if that value is the same. It should be. The length of the track hasn't really changed all that much. So test stops right there. We get one less, but we get a slightly higher average speed and a slightly higher top speed, as you can see. So that might be because of variance randomness. Could also be because the train doesn't slow down quite as much if it doesn't have to make a 90-degree turn. Like I said, I'm going to do more in-depth tests of this with a much bigger sample size to get accuracy. But just as a taste, I'm going to do this at the end of the episode. So number 2 was 7.6, and the top speed was 8.8 second run. So let's try that one more time with the even less sharp corners. And there we are. And we had another slight increase in the average speed with a 7.8 and a new top speed of 9.23. And just as a test, still runs for 11. We're going to run it again without changing the track and see if we get the same values again, or if they change. They will probably change. And this will be the final test before we end the episode. And there we go. 7.79, which is almost the same. And then in 8.93, which is a bit of a decrease. We still have the same amount of seconds runtime, though. So yeah, that is the speed test program, and like I said, you will find the latest version in the description, a link to my repository for my programs, and it should have the out of range check as well as some other convenient features. I'm going to add some better output to it so the button presses required are more clear to force the program to start and such and stop it again. And with that, I will see you in the next episode. Also, just a note, these, of course, don't have to be connected to a computer to work for this. They still fire the required event. You do, however, need the network rail controller below the network rail for it to actually do anything. The track by itself doesn't do anything. But they don't have to be connected to a computer unless you want to transfer data or power. And that is the end of the episode. Hi! Welcome to the end of the video. I hope you enjoyed it. If you did, please click the like button. If you didn't, click the dislike button. Or leave a comment telling me either way, because any sort of user engagement makes YouTube more likely to show the video in searches or suggestions. Now, did you know that I have a page on my website that has a list of all of the shows I have on YouTube, even past ones, along with their respective publishing schedules, as well as a list of all of the past videos that is searchable by series, tags, or title. And I also have a subscription system that is entirely separate from YouTube's that allow you to subscribe to specific shows from me, as well as stream notifications, such as when I schedule or start a stream. So if that sounds useful, do go and check that out. There are links in the description.